Hey guys, Dexter here from Dexter's Workshop. So today I've decided to give it a try. Yesterday I've made some measurements using square waves, and I wanted to see somehow the static performance of this headphone amplifier, which is basically based on one ECC83 and the one 6N6P. I know it's Sunday in the afternoon, so I would have to be at home. But I've decided to finish this week. So basically, it's using an SMPS for the high voltage. It's feeding from 12 volts. It's pulling 0.71 amps for the SMPS, which is feeding around 239 volts as the anode voltage. Then the heaters are taking 1.06 amps for 161P and one ECC83. It's missing 6N6P here, so it will add another 700 milliamps for the heaters. But it's I'm quite very pleased with the performance. I wouldn't expect that. It's putting here is a 600 ohm load, and the performance is very nice. Let's see what we have here. Okay, let me see. So let's start the spectrum analyzer and inject a 1K signal into it, and I'm having like 0.0057 total harmonic distortion and 1112 for the noise. If I'm going to get myself out of here, I'm going to under 0.01 THD plus noise, which in my opinion it's more than enough. Just forget about this spike at 50 Hertz, because I'm at the shop and everything here it's well, 50 Hertz. And also the amplifier is resting on my desk without any kind of shielding. So yeah, we have 0.005 THD and 0. Let's call it 1, okay, because it's me that is leaning over the desk. So 0.1 THD plus noise, which is excellent. Now, from the frequency response point of view, I will do an impulse response first. So I'm using 256K and a sampling rate of 48K. Okay, white noise at -16. And we are going to record this, and we can also see the noise because it's at the output, so the noise is also on the oscilloscope. So we will have, this is the impulse response at this particular moment over the whole frequency from 20 Hertz, if I remember well, to 22 kilohertz. So the frequency response, ignore the spike at 50 Hertz, because I know that if I would go out of here it would not be there. So it's, from my point of view, it's flatline. Let's try and run it again, and just position myself in another angle, just not to lean over the amplifier. And I would expect that spike to be gone. If not, well, it's not. So it's still here. This spike at 50 Hertz, it's because of the 50 Hertz network mains here. So it's quite a flat line, and I really like that. Also, we can do a frequency response, a real-time frequency response, because ARTA it's allowing us to do this. And well, let's see if everything looks fine here. Okay, just let's reset averaging, and it's a flat line. Like I said, just ignore the 50 Hertz, and I'm quite very pleased with the performance. Just to have it like this, I had to add some filtering components. It wouldn't mean much because the noise floor basically and the ripple of the power supply, it's somewhere around 100 kilohertz. Okay, so you wouldn't hear that anyway, and it wouldn't be reproducible by any speaker that I know of, especially headphones. But I wouldn't want to inject so much noise, even though the noise it's very high in frequency. I wouldn't want to inject it in the signal path, because then it will bleed also in the grounds, and well, it's not a good option anyway. So I decided to add a filtering section, which basically it's an LC filter, and was designed with what I had in the shop. The inductors, the coils are 100 microhenries. The capacitors is whatever, like I said, whatever I had, 32 microfarads, and this is 30 microfarads because I had 3 of 10 microfarads, 3 capacitors of 10 microfarads, 400 volts. So it's something that I just had around the shop, and I wanted to see if there is any effect, any benefits of having this kind of filtering. And yes, the noise floor, well, the ripple improved very much, like an order of magnitude, okay, which I'm happy with. Probably the final version will have an add-on board in which the high voltage will go in, and a filtering section made probably by using 3 cells, just to be on the safe side. With this, and I'm sure that the noise injected, the high frequency noise, the HF noise that is around, like I said, 100 kilohertz, would be even more rejected from everything. At this particular moment, under the full load, and this headphone amplifier was not designed to work with this SMPS, because this SMPS was designed to put out a maximum of 20 milliamps, and one section is already taking around 90 milliamps, so it's right on the edge. So I would expect that the ripple of the PSU, it's pretty big, because this PSU is functioning at the upper level of its capabilities. So this amplifier was not designed to work with this. But I wanted to see what's happening and how it performs. So under normal load with this filtering section, I went down to 10 millivolts peak, the maximum ripple, 10 millivolts peak for 240 volts output. I think it's more than enough, this kind of ripple. But yes, it's a high frequency ripple, and like I said, I like to take care of it and not let him bleed in different zones, because it will. Every track on the PCB will act as an antenna, and you will have a 100 kilohertz and over noise in the audio path. Again, doesn't really matter. I don't know if some equipment is able to reproduce such noise, but as long as you keep it low, because if you are going to record or whatever you'd like to do using a digital apparatus, that might give you some artifacts in the analog to digital converter. So it might appear some artifacts because of the Nyquist limitations and stuff like this. So we don't want that, and as long as it's possible to filter, just filter out. Again, I'm pretty pleased with the performance of this particular headphone amplifier. I wouldn't expect to have such a good performance for real. The THD, the total harmonic distortion, is nice. The noise floor, the THD plus noise, is even better. So again, 0.0057 THD and 0.1 THD plus noise. I just like it. I just love it. And I'm sure that that particular 0.1 is because don't worry. So it's because I'm quite prone to all the interference that are around the shop, especially the 50 Hertz one. So I really like it. Well, that's kind of it. I will try and design the the enclosure for it, and then for sure I will get rid of this nasty 50 Hertz spike. Well, basically it's well, just I wouldn't expect to have any noise here, because it's the SMPS is that it's having 100 kilohertz oscillation frequency. All right, guys, thank you for watching this. I hope you enjoyed this. This is Dexter from Dexter's Workshop, and see you next time. Let's see if I will be able to stop this. Thank you. Bye bye.